So here we are to design solutions using model-based, goal-based agent architecture when the problem statement is given. It is assumed that the agent concept, piece analysis, and properties of task environment concepts are already known to the students, and given a statement, student would be able to identify an appropriate agent architecture and would be able to design the solutions after going through this video. Here we have taken an example of the jigsaw puzzle solving agent. Here, the reflex-based agent architecture wouldn't be feasible or appropriate as the agent is not supposed to react to the reflexes. It is not supposed to bring in any happiness in the environment as well as this is not any competitive area and hence utility-based architecture will not be also appropriate. Thus, achieving goal of completing the puzzle is the most appropriate scenario. Thus, it gets mapped to goal-based, model-based agent architecture. Starting with piece analysis, the P stands for performance measure. As the name implies, it has to be measurable and hence it is to be equipped with some rewards and penalties. For example, placement of a correct piece would incur a reward, while as whenever we go for incorrect placement, it should result in some penalty. The wasted moves accordingly can give some penalty, while as completion of puzzle or completion of a section would give some bonus. So this has to be over some scale, but the bonus points may go beyond the scale given. The environment could be physical or digital depending on the detailed problem statement. In case of physical environment, a table or flat surface with physical jigsaw pieces would be there, while as in digital environment, a virtual representation of the puzzle on the computer screen or digital interface would be given. In either of the cases, the environment would contain pieces which are smaller or bigger, less in size or more in size. There could be some theme according to which the jigsaw puzzle might be framed. Typically, the puzzles come with a reference picture and so on. Coming to the environment and the actuators would be either physical or digital depending on the problem statement. The physical environment might have a robotic arm or a gripper to pick, rotate, or place the pieces on the board, while as a digital environment would contain a virtual cursor or a pointer to do the same actions. The sensors are required to interpret the state or the scenario, and for that you require some systems to identify the pieces, detect the colors and so on. So physical environment would contain some vision systems, force sensors to ensure the correct placements, etc. Proximity sensors to navigate between the pieces, while as the digital environment might have some inputs from the simulated image processing system to identify the piece features. There could be some feedback to let us know if the piece placement has been correct or not. Moving on to the properties of task environment, the agent has enough sensors to completely interpret the scenario and hence it is fully observable. Given a state and chosen an action, the agent can be sure about the next state of the environment, hence it is deterministic. The agent, when it performs actions, the environment is not going to change and hence it could be static. The number of percepts, actions and states are finite, making it discrete and not the continuous. Over here, every action taken now depends on the previous action and hence the properties of the task environment is not episodic but sequential for the whole puzzle, and the jigsaw puzzle solving agent is the only agent working in the environment, making it the single agent environment. As we have detailed, the goal-based agent architecture is going to be the most suitable one for such kind of problem statements, and let us analyze what goes in each one of the blocks in the given block diagram. The biggest section of any model-based agent architecture is comprised of how the world evolves with and without the agent. Here we can detail the information about different types of pieces. The pieces do not move themselves. We cannot reuse the same piece at multiple places. Once placed, the pieces remain in the same place unless they are removed. Then the adjacent areas might have similar colors, shapes, etc. Generally, people begin with border. We have to link sections, fill in gaps. Sometimes we might have to go with process of elimination to figure out which pieces go together, how do we group them, and so on and so on. So all these elements are part of how the world evolves. Coming to what my actions do, the agent must know what are actions it can perform and accordingly what could be their consequences. The environment, as earlier discussed, it would contain pieces, reference pictures, the unmatched pieces, the zero or partially finished puzzle, and so on. The state and internal state combined, they can detail the current scenario. The internal state would be given by the percept history, while as state would be interpreted from the current percept. The goal would be the major goal the agent is supposed to complete, but it can be divided into some sub goals, and the agent can work on the sub goals, which in turn are going towards the final goal. For example, over here, organizing the pieces or building the border or solving the remaining gaps, verifying the completion could be some of the sub goals listed over here. For every action the agent can perform, the agent must know what are the outcomes of each one of them so that whenever it comes to weigh one action against the other ones, then the agent would be able to make a choice. The agent's action in at any instance depends on the percept history and the current state, interpreting the whole scenario, the knowledge of how the world evolves with and without agent in case of this jigsaw puzzle, and what could be the outcome of chosen action given the list of goals or sub goals, and is it going to go towards the goal or it's not going to affect the goal list, etc. Let us consider a problem instance wherein the agent is solving a world map puzzle and the piece in hand is Mongolia, wherein the parts of Africa and Europe are already completed. In the current state, there are various actions the agent can take, and each one of them might be applicable or might not be applicable. For example, when you have Mongolia in hand, you can identify the Asia section on the puzzle and focus on that area. Or we can search for neighboring pieces already placed in Asia and try to fit in this piece along with them. Or we might have to rotate the piece systematically and retry the placement in case if it goes in the given area. Or in worst case, no fitting neighboring areas are found. In that case, set aside Mongolia piece and focus on the other pieces which could help expanding the Asia section. So given multiple actions the agent has, which action it should perform now? So there might be multiple actions, but all of them might not be exactly useful. So in this particular scenario, it can focus on Asia section as Mongolia is part of it, or match the pieces, physical features with its neighbors and try to fit in over there, or worst case, leave the piece aside and move on to the other pieces. Or possibly, you are successfully able to place the piece, and then you can move on to the next piece or next section and so on. Thus, we can design the jigsaw puzzle problem agent using goal-based agent architecture following all the sections given in the agent architecture block diagram. Thank you.